The 15th year of Guangxu, the Eiffel Tower rose from the ground in an era where computers were not yet invented. How was this achieved? Before construction, the engineers selected 4 suitable locations as the foundation and excavated the foundations far from the riverbank until a huge pit 7 meters deep was dug. On this solid surface, workers dug out 4 small rectangular pits. The same procedure was carried out on the other foundation. Afterward, workers poured a large amount of concrete into the small rectangular pits. When the rectangular pits in both foundations were finished being poured, workers then placed a huge stone block on each concrete pour. These stone blocks were a mixture of small stones. When making these stone blocks, workers would place a bolt about 6 meters long on each block, and along the bolt built a pier inclined at 54 degrees. After completing these, the next step was to build a ring of masonry walls around the rectangular foundation. Then poured concrete into the entire rectangular foundation. At this point, the 2 foundations away from the riverbank were completed. Next, we will build the other 2. Since these 2 were near the river during excavation due to the soft ground, river water continuously seeped in. To solve this problem, the engineer used a remarkable technique, which is caisson construction. Workers would first prepare the caisson and use a crane to place the caisson into the foundation. Let's look at the caisson structure. The bottom of the caisson is a working chamber. The space inside is very open. There is a ladder inside the working chamber. It goes up through a long vertical shaft to the top of the caisson. Then the caisson is placed entirely on the foundation surface. To maintain stable air pressure in the working chamber, workers use a high-pressure compressor to pump air into the working chamber. Then there are 2 entry points in these 2 locations. After the worker enters through the upper entrance, this entrance is closed. At this time, the worker has arrived at the second entrance. The operator uses a compressor to pressurize this chamber. When the pressure matches the pressure inside the working chamber, the worker opens the second entrance and can then enter the working chamber to work. You might have a question: won't water enter the chamber? Actually, no, because the pressure inside the working chamber can completely prevent water from entering. Then, as the workers continuously excavate downward, the caisson slowly moves down under its own immense weight. When they reach the hard bedrock layer, workers will stop construction. Afterward, workers will remove all the equipment on top of the caisson and the shaft and fill it with a large amount of concrete. Then it's the same. On the concrete slab, workers added a huge stone block made of a mixture of small stones. Similarly, long bolts were placed inside, and a pier inclined at 54 degrees was built. Then, using the same method, workers continued to build 3 more identical foundations. After completing these, workers built a ring of arched walls around the rectangular foundation. Why were they built in an arched shape? This is because if masonry walls were built, due to the uneven water pressure from the river, the direct force on the masonry walls might cause the walls to bend. But if we build arched walls, then pressure from any direction will only be transmitted downward to the foundation, thereby helping to disperse pressure and enhance stability. Next, it's still the same. Pour concrete into the entire rectangular pit. At this point, the 4 perfectly symmetrical foundations, each separated by 125 meters, were completed. The next step is to add a large base plate onto the bolts of each pier. After completing these, we can install each leg of the tower. These high cross braces are prefabricated. Workers would assemble them one by one like building blocks. They had a question: how were these steel cross braces connected together? The answer is using rivets. Workers would heat the rivets until they were red hot, then clamp them into the corresponding connection holes. Another worker uses a hammer to drive these rivets directly in. Using this method, workers eventually built 4 supporting legs reaching a height of 57 meters. The inclination angle of these supporting legs needed to be very precise. If there was a slight difference, it would be catastrophic for the tower. However, these problems were considered by the engineers from the beginning. When connecting the bolts on the piers, they left some room for maneuver so that after the supporting legs were built, minor adjustments could be made. But each supporting leg weighs 1,500 tons. How could such a massive weight be adjusted? Workers built 2 wooden scaffolds at the base of each supporting leg. Also, inside each base plate, the engineers installed hydraulic jacks. When the angle needed to be adjusted, workers would use the hydraulic jacks to adjust the supporting legs. After adjusting the angle, workers built another scaffold in the middle section of the supporting legs. The purpose of this scaffold was to assist in building the tower's central platform. Workers used large steel cross braces to connect the supporting legs horizontally and installed a platform on top. Also, for aesthetics and stability, in the middle of each leg, workers installed 4 huge arches. With this central platform, workers then built a large steam crane on top to lift and position various installation components. Then it was the same, using a large number of steel cross braces to build the tower's second level. After the second level platform was built, the tower's height had reached 150 meters. Then they continued upward to build the third level. Its shape narrows the higher it goes. This design lowers the tower's center of gravity and significantly enhances the tower's resistance to wind and earthquakes. When the main body of the entire tower was built, the entire tower's height had reached 300 meters. Later, a television antenna was installed on top of the tower. The final height reached 330 meters. The question is, how does one ascend such a tall tower? The answer is hidden between these steel cross braces. Inclined elevators were built on them. The elevators can move along the inclined rails. Their power comes from these hydraulic systems. The hydraulic system is equipped with many rollers and connected by steel cables. When the piston of the hydraulic system moves backward, it can pull the elevator here to move upward. When visitors reach the second floor, they can then take this straight elevator and eventually go up to every floor.